All right, so I'm gonna walk you guys through. This is the week 9 worksheet. This is 3-105 A, B, C, D, or sorry, 105 A, B, C, and then 125 A, B, C. So one thing you need to know about the tangent ratio. So tangent, or as we know it on our calculator, is tan. This is what they call a trig function. So it describes a slope ratio, rise over run, between two sides of a slope triangle. So we're going to use it as a tool in this class to be able to solve some of these problems. So the formula we're going to use is tangent of theta equals opposite over adjacent. Okay. Now tan, we already talked about tan. Tan means tangent. Theta is just a variable for angles. So it's like x, but for angles. Opposite is the opposite side of wherever your reference angle is, and then adjacent just means close to. So let's take a look at our first triangle here. So the angle in question here is 8 degrees, right? So that's going to be our reference angle. So one way that I can write this tangent ratio, right, and one way that helps a lot of students is to draw themselves on this angle right here. So there you are. You're smiling because you're doing math. This is me. And in this position, I should mention there are 3 parts to a triangle. There's a hypotenuse, which is always the side that's longest away from the 2 legs. And then we're going to be looking for opposite or adjacent sides. Now these are going to be different depending on which reference angle you choose. In this case, we chose this reference angle. So from where I'm standing right here on this angle, what's opposite of me? T or 82? Opposite of me is T. So I'd say T is opposite. 82 is really close to me. It's adjacent to me. Okay. Now keep in mind this hypotenuse here, this side over here, is also close to me, but it's the hypotenuse, which makes it unique. It's not the adjacent side, as we would call it. So now we have everything that we need to solve this problem. So we'd say tangent, if you remember, tangent of theta equals opposite over adjacent. So tangent of, in this case, our angle theta is 8 degrees. So tangent of 8 degrees equals opposite, which is t. This is how I draw my t's, over adjacent, which is 82. Okay. Now all I have to do is get t by itself. So what's happening to t right now is it's being divided by 82. So I multiply by 82 on both sides, and I get 82 tangent of 8 degrees equals t. Okay. So now I get to pull out my calculator. Now, one thing to note real quick, make sure your calculator is in degrees, like it is right here. Because otherwise, if you do radians, you do the problem completely correctly, but once you plug in your calculator, you'll get it wrong. So, going back, the tangent button is right here. Okay, so keep that in mind. And let's look back at our equation that we have. It's 82 tangent of 8 degrees. So I'd say 82 tan 8. Enter. And that gave me 11.52. So I would say t equals 11.52, or approximately, right? It's not exactly 11.52, but it's pretty close. Okay. Now that's the side length for this side right here. Now keep in mind there's another way we could do this, and let me redraw it over here. Okay, this is 8 degrees, it's a right angle. This is 82, and this is t. So we could figure out what this angle is right here, because all of the angles in a triangle add up to 180. So knowing that this is 8 degrees, this is 90 degrees, together they make 98. So 180 minus 98, that must mean that the remaining angle is 82 degrees. Okay, so now we can create a tangent ratio. Tangent of 82 pretend we stand right here, is opposite, which is also 82, coincidentally, right here, opposite this side, over adjacent, which in this case is t. So now all we have to do is solve for t. Well, in this case, we're dividing by t. So I'd multiply t to both sides. So I got t tangent of 82 equals 82. Now I need to get t by itself. Right now it's being multiplied by tan 82. So I'm going to divide by tan 82 on both sides. Okay. So I'm going to plug into my calculator. T equals 82 over tan 82. So let's go ahead and do that. And I get, what do you know? The same exact answer. So you could do this two ways. It doesn't really matter which angle that you choose, because you'll get the same answer. So let's go back down. Let's just do a couple more examples. If you completely get it right now, then perfect. You don't have to watch anymore. But let's do a couple more example problems just to be sure. So right here is 75 degrees. That's where I'm set up. So opposite of me is 12, and adjacent to me is P. So I would say tangent, what's my angle? 75, equals opposite, which is 12, over adjacent, which is P. Okay. Need to get P by itself. Another way you can do this is cross multiply. So you could either multiply P to the other side like we did up here with T, or you could cross multiply if it makes it a little bit easier for you. So 1 times 12 is 12, equals P tan 75. Right now P is being multiplied by tangent of 75. So we divide by tan 75 on both sides. And we end up with P equals 12 over tan 75, which is about 3.22. And that is the side length P right here. Okay? So now, there's one other type of problem you might see. We're not going to get too deep into figuring out angles that we don't know yet. We'll get into that next chapter. But for now, I want you to look at this triangle and I want you to identify certain parts about it. What do you notice about this triangle? Go ahead and pause for a second and think about what you notice. So what I notice is that this side right here, this 5 and this 5 are exactly the same. That would make this an isosceles triangle. Okay? And what isosceles triangles have in common is that they all have two of the same sides, and the sides that are opposite of those, or sorry, the angles that are opposite of those sides are also equal. So that would make this one also theta, the exact same theta that would be up here. Those two are the same because they're both opposite of the 5. We talked about this a little bit in chapter 2, I remember. So knowing that, and knowing that all the angles in a triangle must add up to 180 degrees, this is 90 degrees. If I add all these together, 90 degrees plus theta equals 180. That would leave me with combined like terms. 90 degrees plus 2 theta equals 180. Subtract 90 to the other side. Get 90 equals 2 theta. Right now right now theta is being multiplied by 2, so I divide by 2 on both sides. So theta equals 90 divided by 2. Why not? Let's use the calculator. 45 degrees. So theta equals 45 degrees, right? So this one's 45, and this one's also 45. Okay, so that's another way you might see one of these problems coming up on the exam. So that's pretty much all there is to tangent ratios. Just remember tangent is equal to opposite over adjacent, and remember that there's two ways you could set it up, right? Because you could find either of the angles. Usually this way is a little bit easier when you see the variable that you're looking for the side, when it's in the numerator in the top of the fraction. Usually it's a little bit quicker and simpler than when it's in the denominator. But Either way, you'll end up with the same answer. So I hope this was a little bit helpful. Complete a little bit of your homework. Let me know in class if you have any other questions. Good luck.